We're going to focus on linear relations. I'm going to talk about some of the background knowledge you guys have and then how we can solve them by looking at specifically data. Now, a linear relation on a graph. Does anyone recall what relationship or shape or form it would take on a graph? What do linear relationships look like? Straight lines. Okay? So this would be considered a linear relationship. This could be a linear relationship. As long as we create a straight line, that's going to give us a linear relationship. Okay, so there's our first example of looking at one. Our second example, let's talk about an equation. Now, we're writing all of our equations like f at x. Okay? And let's say I have 3 over 4x plus 8. Okay? When we're looking at, this is called a polynomial, but this equation specifically, we look at a variable, and we always focus on the variable with the highest degree. Okay, by degree we mean the exponent is to. So what exponent is this x to? 1. It's technically a 1. So anytime the highest exponent of the variable is the number 1, it's what? What type of relationship do we have? It's linear. This would be a linear line if we were to have graphed it. Okay? So one of the rules is to look at the variable, whatever exponent it's to. So if it's the exponent 1, we know we have a linear relationship. Okay? Now, another way we could do this is we have a whole bunch of coordinates here. We could plot all of the coordinates and see if we can fit a line through them. But another way we can do this is called first differences. And what we're going to do is we're going to be subtracting the y values. Now, first of all, we're going to have to determine which is x and which is y. X on a graph is always your independent variable. Y is always your dependent variable. So we're talking about maybe a hockey player or a soccer player. Hockey, there's too many goals for soccer. Minutes versus goals. Okay? So for every minute I'm on the ice, I get more goals. Especially if Jerry's in that. So we're looking, minutes are our independent variable. Okay? And our dependent variable are goals. So the more time I spend on the ice, the more goals I'm going to get. So what that means is our x will be minutes and our y will be the amount of goals. Now, we'll always have to do when we're doing first differences, we're subtracting y values. Now, first things first, we have to make sure that the x values increase by the same amount. And what are they going up by every time? 1. Okay, so as long as they're going up by the same amount every time, we can use first differences. So what I'm going to do is I'm going to take the second value and subtract the first value from it. And this is our first differences. So I take 3, subtract 0, and what will that equal? 3. Good. I then take the next number, 6, and what do I subtract? That's right. I subtract 3. What am I going to get? Excellent. 9 subtract 6. 12 subtract 9. Right? And then 15 subtract 12. Good. So, what this check is we've looked and all of our first differences, are they the same value? Yeah, that's right. They're all the exact same value. So what that means is this is a linear equation. If the first differences are the same values, then it is a linear relationship. Okay? If it's not, if these numbers were different values, maybe this was 6, this was 12, this would not work. Okay? So, with that in mind, these are 3 ways we can check if something is linear. On a side note, what we're also going to do is we're going to find the domain of this specific one here, domain and range. So if I were to write the domain, minutes are continuous, right? Time is always counting. There's always seconds involved. So what that means is instead of writing all of the actual values of minutes, if I were to write all those numbers out, it'd be very tedious. So how do I represent that when I'm writing domain? That's right. X, ER, or X is the element of all real numbers. Okay? So that means we're going to do every single value, and there is a restriction. What's the lowest amount of time I spend on the ice? 0. And what is the most I've spent on the ice? 5. So we have x is going to be less than and equal to 0, but x is also less than 5. Sorry, 0 is less than x, and x is less than 5. Okay, so here's our domain. And what about the range here? Now, technically, we're going to talk about technical things here. Technically, goals, can I really have a 0.5 of a goal? No, but I'm in Jerry's head, so every time I get closer, it's like more decimals towards a goal. All right, so that's how we're going to think about it like this. So this is, imagine this is continuous. How would I represent the y? Y-E-R, such that what? What's the lowest value? 0. The only way that happens is if I'm not on the ice. And then what's the most I'm going to get? 15. So really the easiest way to kind of do this, set up like that, we know our y is going to be in the middle, and we just point downwards. The larger guy is pointing to the smaller ones. Okay?